Good morning, everyone. It's nice to be here today and be with all of you and discuss a topic that is, very close to my heart. It's observability, and then, how are we bringing in and using AI in the enterprise. But before I get started with what I wanted to cover, and I know, most of you have probably have heard this term observability, but can I just see a raise of hands that, how many people are familiar with the term observability? Okay, and if you can just keep your hand up if you understand how it actually makes an impact to the businesses across the world. Okay, so then that's good. So my session is pretty relevant. And I usually put this definition up, and every time I put it up, I actually think of the definition of a motor in Three Idiots. If those of you who have seen it, and they kind of look at it and they're like, okay, yeah, you can have all this complicated jargon. Is it really that complicated? But I think we've chosen the words to use over here and highlighted them as well, because it's very important that observability really helps us understand system health, application performance, and customer experience, right? These are three aspects of it, and all three are very important. Like we can't just focus on the infrastructure or the system, we also have to focus on the customer's experience. And so that, when we do it with real-time data and analysis, really helps us to understand and helps us make real-time decisions of what's happening in our systems. And all of us build complex, the systems that we have today are very complex. They're distributed, there's so many pieces, moving parts to it. It's very difficult to figure out what's going wrong in your system if you don't have a visibility into it. You could have a bad code that gets released and that creates a problem. You could have an infrastructure outage, that's creating a problem. I mean, there are tons of things that can happen. And unless you have an end-to-end visibility of what's really happening in your system, you're going to have outages, you're going to have issues, and that creates a business impact. And so I want to put a scenario in front of you today, right? Like, think of each of us, like think of your own daily life, think of each of us, right? Like, we wake up in the morning, maybe like the first thing we do is probably like pick up our mobile phone, check messages, look at the news, look at some articles, and then kind of move on to getting ready to go to work. I mean, nowadays probably things have become a little remote, maybe it's coming back to going to work, but on the way, maybe we stop somewhere and have food. Maybe we order some food using an app. Maybe we pay for it using another payment app which we have on our phone. After that, we get to work. Once we get to work, we use a whole bunch of applications to do our daily job. And then, we're again maybe ordering lunch from somewhere, paying for it. Coming back home, maybe we order some groceries on the way so that they reach home through a e-commerce app before we get home. Those are available for us to use. Have dinner, and then we close by maybe watching something on OTT or maybe going in and looking at what's the weekend entertainment. Should I go book tickets somewhere, book a trip somewhere? All of this is done through certain different platforms that we use, right? So our lives are so integrated to these digital experiences that when we have a disruption in these digital experiences, it actually creates an impact to all of us. And so having a consistent, uninterrupted digital experience is what we all want today. We don't like it like when I'm watching something and it kind of starts, the scroller starts spinning, I'm like, oh my God. And it generally happens on these live events which you're watching. If it's a cricket match or something like that, when the India-Pakistan match happens, the systems really are tested to their limits. So observability actually helps us create those uninterrupted digital experiences for customers. And so our mission at Neuralink is to eliminate those interruptions in digital experiences. Pretty simple mission. That's really what we want to do. That's what our customers want. That's what their customers want. But it's important for us to look at how has the technology space itself evolved over the last 3 to 4 decades. And it all started with client-server computing. you had the PC, you had monolithic systems, you had infrastructure that was in one place, you were just monitoring those. We started with infrastructure monitoring. It was pretty easy because you didn't have a lot of distribution of systems that were there. And from there, architecture evolved to go more microservice, three-tier architecture. Actually, probably went to three-tier architecture first with the interactive web. And as that happened, systems became a little more complex. They were, a little bit more needed. We needed to move from infrastructure monitoring to application monitoring. And then you had the third generation where we went to the cloud and mobile, where you had more microservices, you had more mobile apps coming up. The computer moved from the desk to the pocket, right? Like that's really what happened. And so, and then we moved from like on-prem infrastructure to cloud infrastructure. That created a lot more complexity in the observability space as well. If you look at it, where we needed to actually have what is called full stack observability, which actually helps you to go through the whole of your distributed stack to really understand what's happening, and really have things like real-time user metrics that actually help you understand what's happening at real time inside your systems, rather than a matter of fact or after the fact kind of thing, which is not very helpful. But along with, and we're moving into the AI age. That's where we're going now. And with the AI age coming in, we're moving into a lot of LLMs getting deployed, huge data pipelines, a lot of data churning which is happening. And so observability is going to make a further shift now to move from full stack observability to what we think is actually going to help observe systems that are going to be built for the future. And I'll cover more about that as I go along. But the business challenges haven't really changed. They've always been there, right? Technology, the expansion of technology or the evolution of technology has created operational complexity, and that operational complexity, has created a need for much deeper observability and monitoring of systems. IT spending has exploded, right? And IT spending is exploding. When IT spending explodes, the business expectations also grow. They're spending, millions of dollars on this infrastructure. It better be up. It better be available. It better run. Like, why am I having an outage? They're not very happy about that. Now, because we now have the computer in the pocket, the customer's expectations have also grown in terms of everybody wants everything to be self-service now. Nobody wants to actually go and, stand in a line, go to a place, try to get something done. Open it up, I'll do it myself. That's where we are probably going to. And as that happens, you need to create better experiences now, because you're opening up a lot of things to customers. And as you open them to customers, they are going to have higher expectations of availability, not just availability, but being able to do what they want to do. And as our footprint has increased and as the distribution of systems increases, cyber risks are also becoming higher, because of the fact that it's, your system can be compromised in so many different ways with so many different. It's probably a lot easier than it was 20 years ago to do that. So the business challenges are increasing. Observability has evolved over a period of time, as have the architectural technology that we've actually implemented. And as I said, that technology introduced monitoring complexity, right? So we have so many different teams now. Teams have been siloed. Your telemetry, which is basically your data itself, is now siloed. You have so many sources of data that are actually coming in. All this data is essential data, but you need to actually integrate all that data together to get that integrated picture. If you don't do that, you'll have data in different silos. It doesn't actually help you get the total picture of what's happening in your systems. And today's observability landscape, I'm sure many of you who have used it or who are using systems, you would have multiple systems that you're using today, multiple tools, multiple systems in order to just monitor your system. And that adds to complexity as well, because you have to stitch all these, each tool that you use gives you certain view of the data, and you have to stitch it all together now yourself in order to be able to see what's actually happening. So it adds that additional layer of complexity. And from a business standpoint, low uptime, we talked about it. Low uptime is a revenue loss. But along with that, we're also losing engineering productivity. That velocity to be able to deliver stuff goes down now, because we're spending all the time trying to firefight issues which are coming in our production systems. And all the time is actually spent And some of them are repetitive issues. They keep happening. They keep happening. Every 2 weeks, you keep getting the same issue. And the developers don't have a time to actually go fix the root cause because they're spending 12 hours on incident call. So that's a huge issue. And then the overall, like if a CTO or a CIO was watching it, looking at this, they get a huge bill for the tooling and the engineering cost, and they're like, why do we need all these tools? Like, what is the advantage of all this? Why do I need, like cloud expenses go up? Why is my cloud expense going up? Like, so we have all of these things that are coming in that are creating problems from a business standpoint as well. Now, I spent, as Arvind said in my introduction, I did spend a long time at Walmart. I helped build a lot of the systems that were there, and we looked at generationally, how things changed at Walmart. And I wanted to walk you through a little bit of that journey and talk to you about some of the things that impacted us at Walmart. We had obviously a very huge network of retail stores and e-commerce and mobile commerce as well. So it's a pretty complex operation, world's largest retailer. But you'll be surprised, like all those years back, that we had the same problems. All our applications were monolithic, and they were monolithic for a reason. The reason was that the stores that we had did not want centralized systems, and they did not want applications on the cloud, because they were worried if there was an outage on the cloud that there would be a region of stores that would be taken out at that point of time. Whether that's a true or not, I'm just presenting the picture to you. This was the pushback that we got, right? Nothing going on the cloud. We want our autonomy. We want stuff in the store. You need to deploy it on on-prem, and we need to be able to hold our own destiny. Now, what's the problem with that? Now, the business wanted to really look at advantages that we could get in terms of like synchronizing inventory and having a single picture of inventory, having a single picture of price between store and online, or between stores itself. And because we had these distributed systems that were deployed in each of these stores, you couldn't get that centralized picture. And we wanted to build some use cases, for example, where, hey, if an item's not available in a particular store, we can show you that it's available in another store that's like 5 miles away. How do you do that? You can't do it unless you have a centralized view of inventory. We wanted to be able to show you that the price online and the price in the store is we wanted to match. We couldn't do that because we couldn't have visibility of what the stores were doing, and the stores changed their prices dynamically through a day. And when we were doing all this, we realized that the technology had to change in order to do that. So we had to move people onto a more microservice-driven architecture, bring everything together, and then go deploy on the cloud, which is fair. So we had some observability systems that were doing point-to-point kind of checks in each of the store. It meant that the observability, the mechanism we used for observability also had to change. Right? So we had to go back and redefine what it was. So what did we do? We had to look at some things like centralized logging. We had to look at distributed tracing. We had to look at a bunch of these things which would actually help us on the new architecture. First of all, it took us a long time to get the architecture migrated to the microservice-driven architecture. But when we did that, we realized that we had to make changes to our observability. And so once we did that, and we started to build systems that could observe these centralized pieces, like you would know, oh, inventory is going down. So why I'm saying this is because observability is not just for your technology infrastructure, but you can also do business metric observability, which gives you a lot more advantage from just the technology systems that you're monitoring. And that business observability actually helps you understand now that, oh, inventory is going down. Either I need to place a replenishment request, or I need to maybe move. I'm seeing a larger demand for this item in this particular store. Let's move the inventory from here to there. It's not going to, it's pretty nearby. We can do that. This gives a lot of power. It gave a lot of power to our business to start making much more economical decisions. Instead of trying to ship something from a warehouse somewhere, it's actually available closer. You could actually make those decisions much faster because we were able to observe these patterns. The third aspect is cloud costs. Okay, so what happened for us then is, because we opened up to public cloud, and I'm sure many of you will relate to this, we opened to public cloud, auto scaling, wonderful, great feature, everyone loves it. You have dev environments, QA environments, pre-production environment, production environment, and generally we keep a good watch on what's happening in production, but the dev, QA, and all these smaller environments which are there, people have their own flexibility. They can go do whatever they want, and they, spin up environments all over the place. And when the CTO gets the bill at the end of the month, is looking and saying, "Hey, Rohit, what happened? Why am I getting this bill? What is wrong with it? Like, what do we do?" And what we tended to do at those times was becoming a bit more bureaucratic in the organization. Say like, you need 4 approvals to get one environment created, which then creates a huge productivity loss for the developer. Now, we don't want to penalize people who are doing their job well versus trying to also manage the cost, because it's a realistic thing. If you just spin up environments and don't bring them down, it's like we all have kids who take their toys out, throw it all over the house, and when you ask them to keep it away, they don't keep it away, right? And you have to go back and clean up behind them. So the point is, what we did is we actually introduced observability on the infrastructure. And we were able to go back and look at data patterns on each of these environments that were coming up, and we were able to send alerts, proactive alerts, to the owners, the tech owners of those environments, the leaders of those environments, so that they could go back and make a decision on whether those environments needed to be shut down. We found that no action was happening on those either, right? So what we did as a next step was we actually went back and auto shut down those environments when we found that there was no CPU utilization on them. There was no actual, it was like no heartbeat, dead after a point of time. So that way we were able to kind of, control the environment, control the cost, and really help reduce it. What it did as a offshoot was also help us build a better engineering culture, where people then realized that there were systems, there was like an alert, there was a list which went out, things were being tracked. And so we found that, our team started to become a little bit more responsible for the environments which were getting created. And then they didn't want their name to show up in those lists, and they didn't want those alerts to be going out to their leaders. And so things started to get cleaned up a little bit better. So that culture really started to get built in the organization. The other aspect which is very important on observability, and what we felt at Walmart, and this generally happens with large enterprises that have a brand value that they need to protect. You generally don't want to see your name in the newspaper, because any security breach, any violation, any compliance problem will make big news and also cost you a lot of money at times. So we built proactive mechanisms to go in and look at our security, to look at compliance regulations, look at vulnerabilities, and do vulnerability checks, and integrate it into our build process itself, and kind of make sure that these are happening through observing and adding it into our observability tools itself. That helped us to proactively go address these security issues before shipping code out, because once you ship, it's a vulnerability, it's publicly available, especially on e-commerce systems, everyone's using it. You could get hacked pretty easily. And so that was a big win, especially in the fact that it's very hard. You don't have a tangible dollar value you can attach to that, but you would have, it's like the security guard who sits outside. You don't realize that person is there until an incident actually occurs. So and the last one that I want to cover in terms of what we did was general tying together. I talked about the tech stacks, and I talk about having a distributed tech stack, and I talked about having tools that, like multiple tools in an environment, right? Where you have 5 different tools and you have to kind of stitch information together. What we did is we invested into a full stack observability tool. So what did this full stack observability tool, and what is full stack observability? It's really about looking through the entire stack, but it's also about tying together 4 pieces of information. What we call metrics, events, logs, and traces. Right? So think about this, like many of you who have been through incidents, who have seen these incidents which occur. When an incident occurs, what is the first thing that we do? If I open my logs and start looking at my logs and starting to trace what's happening there, there's so much noise in the logs, I can't go figure out what's happening. So that incident is really tied to a set of metrics. That's the top level thing that we generally go look at. If there is a drop in some of my key metrics, I know there is a problem in my system. The moment I know that, if there is a good mapping to a set of events that are triggering those metrics, I can clearly go and figure out, hey, here's my metric dropping. What are the set of 10 events that could cause this metric to drop? So I start to zero in and narrow in onto those 10 events that are actually there. Then, once I trace those events, those 10 events, I can now go to my logs and go look at specific parts of it where I can go clearly figure out what's actually happening. Now, when you stitch all of these 4 things together, that experience really becomes good, because now when a metric starts dropping, I can go start to kind of look at, what exactly caused that, and I'm able to correlate it together. If you don't have a full stack observability tool, you have to go do this yourself. You might have 4 tools that are actually something that's doing great log analysis, something that's doing great metric capture. To get that picture, you're doing the effort to actually tie all these things together. Your teams are doing this effort. And so when your teams are actually doing that, that's the productivity loss that's actually coming in, because you don't need to do that. You shouldn't be doing that. This is a solved problem in the industry. You should really go and look at how full stack observability is going to work. So we invested into that, and we realized that we saved a huge amount of time from a productivity standpoint, which again ties back to dollars. I can move those people in to go do the most important things that they need to do, which is about trying to grow our business, trying to build more features, and trying to make sure that we get more customers through the door. That's really what we are there for, and that's what we should be doing. So that's what my team was actually focused on, and how we really solved the problems at Walmart. So I put this up, but I think it kind of gives you a picture of what all we had to do in order to solve that problem for a large enterprise. Now, the current challenges that tech leaders have, we talked a little bit about it, and I talked up through my experiences. Like now I talked about controlling cloud costs, scaling AI across the enterprise is another big thing that is going to come in, and I think it's already probably hit us, and it's going to hit us more and more as we go through, because everybody's building AI-based solutions at this point of time. Do we fully know how to monitor all of our AI solutions? Maybe we are learning on the go as we kind of look at the different kind of applications that are getting built today. And that is the next generation that I was actually talking about. And I believe that all of these challenges can be addressed, just like we've addressed everything that has happened till now. We will also kind of be able to address the AI challenge which is coming up in front of us in the coming years. And so for that, we believe that the future of observability is going to be intelligent, or intelligent observability. So what do we mean by intelligent observability? Now, let's think of what I just told you all this time in terms of observability. And observability is still telling you something after the fact or during the fact, right? System has gone down, great, I'll show you all the data about it, go fix it. Or I'll show you, here's what's happening in your system currently, but let's be aware that the incident has already occurred at that point of time. The business impact has already started at that point of time. And the longer we take to be, and again, like I said, without full stack observability, you don't know what's happening. So now you're running helter and skelter to kind of find out, okay, my log, my metric, how do I tie it back? Which event is actually there? All this is taking time and creating a huge impact in our systems. Now, ideally, we should be able to tell you that before it occurs, or at least be able to at some point. Like it's like, I always compare this to going to a doctor, right? Like you go to a doctor, and if a doctor tells you that you already have a problem, and if you regularly visit the doctor, you ideally want the doctor to tell you beforehand that something's wrong with you. And today we have enough data. We have all the data. We have all the events. We have all the past incidents. We have all the information available to us. We are just not tying that data back together and building the intelligence and the smarts on top of it to be able to look at patterns to say, hey, in the next 30 minutes, it looks based on what this pattern that we see, you're potentially going to have a problem. That is what intelligent observability is actually going to get to, where we can get to a state of predictability, where we can get to a state of being able to tell a customer when something is going to happen. And obviously, it's going to take some time. As you have to get the trust in the system. Models have to be good enough. All of that is yes, but the technology is not stopping us today. The data is available to us today. We just have to kind of put all of this together, and that's how we are viewing the intelligent observability. Now, in addition to that, there are a lot of other mundane activities as a part of this observability platform that can be automated. When you think of things like incident management, right? Now, you think of incident management, how much time do we spend on just documenting all the information that happens on an incident? Hell of a lot of time is spent. We repeat a lot of, how many times do we have to go into different meetings and explain to A, to B, to C that, what happened, what happened, what happened. Everybody wants to know what happened. And you have to keep doing that over and over and over again. It's a productivity loss for our teams, for our engineers, for our developers, for management. Everybody is losing time. The truth of what's in there is really in the code change which is actually happening, or the change which is happening to go fix that incident. And technically with our intelligent observability and AI models, we can go back and generate all the rest of the documentation which is there around it. To say, this was the change that happened, go read it. And you can even convert it to a nice presentation and kind of make it out there, and it's all ready. And every time you make those changes, you can actually go back and make sure that you don't have to spend a lot of time doing all the mundane tasks that we're doing today. The other problem is in large enterprises, you have, like we talked about earlier also, the same incident occurring multiple times, right? And when that same incident occurs multiple times, you don't have visibility, like one part of the organization doesn't have view into other part of the organization that the same thing happened. So somebody has already solved it, but other people also trying to do the same solution right now. And there's no centralized way to actually go figure that out. With intelligent observability, we'll be able to, with the view into the past data, you can clearly go back and say, hey, this incident occurred, in your organization, it occurred 4 times. This is what the teams did the last 3 times to go fix it. Maybe you should start with, and give you a playbook, right? Like straight away I can give you a playbook and say, why don't you start with these, try this, try this, try this, try this. It gets you to a point where you can actually go and start to resolve much faster. And the future, even if we go one step further from there, is really about, if I have a playbook and I know what needs to be done, why can't I automate the thing? So we want to get to a point where we can actually have developers start to go focus on, let's go fix the root cause of this problem. You don't have to sit on this incident call, write the documentation, do the management of this, understand what playbook to go run. Forget all that. Move out. Go fix the root cause. If this occurred 4 times in my organization, I want you to go find out why it's occurring 4 times and go figure out, like some of these may not even be technology related, by the way. Like some of these incidents may occur because some business process broke down, or somebody went and updated some configuration file with some wrong information. Now, I don't think AI is going to fix all those problems at present. It probably still requires human intelligence to go figure out what is really happening over there, understand if it requires alignment with other people, go fix. So really spend your time on doing all those things. Like don't waste your time on activities that could be automated. And that's really where we are going, and we believe that the future of this observability platforms are going to be intelligent, and that is what we are focused on completely at Neuralink, trying to make these happen. So I'm going to stop here. And I'd love to open up the floor if there are any questions. I'll try to answer whatever I can, but happy to open the floor up.
Questions?
Hello. Hey, so as you mentioned in between that companies are using multiple tools to solve different problems, like one might be a great log management, other might be a great with matrices. What is the trend that you're seeing? Are the bigger organizations moving more and more towards consolidation? Because what I have seen after talking to some of the big companies like Hotstar and Jio in India, they still have their stack divided across something that is very great for matrices and something that is very great for logs. So what you have seen up till now?
Yeah, it's a great question, because that's the stuff that we're dealing with on a regular basis today, right? Like it's about trying to educate people that by fragmenting your systems. Now, generally, why do people fragment systems? Let's try to understand that first. You don't want to put all your eggs in one basket. If somebody doesn't give you, you'll go to somebody else, I'll go to somebody else, I'll go to somebody else. And that's why you tend to, fragment it. So you think you're putting some competition in the system, saying, if A didn't do it, B will also do it. I'll get B to do it. But you also have to understand that while you're doing that, like I said, you're putting more effort, effort on your own team to actually put all these together. So part of what we are doing with enterprises today is to really go back and educate them on the fact that full stack observability is really the way to go. And by fragmenting it, while it may solve some of the, like, you know, the CTO's problems in terms of, hey, don't put all the eggs in one place. If one vendor doesn't do it, go to another vendor, you know, that kind of thing. In the short run or even in the medium run, you're creating a problem for your own teams in terms of productivity. So while you're right, I don't think a lot of consolidation has happened at this point of time. I think that is the way that you can actually go and you know, kind of save a lot of productivity on your own engineering teams and have a better view into what's happening in your system when you can find the right full stack observability tool that is tying all these things together. And so when you test and when you go and evaluate these tools, right, evaluate them to see if they're actually giving you that full stack observability, right, and go in for a tool that actually gives you full stack observability. Instead of somebody who does, you know, maybe logs great, or somebody who does, you know, application performance monitoring great, somebody else who does something else, security, you know, controls great. You need somebody who can do everything well and tie it all together. Any other questions? Okay, we have somebody.
Hey, so we are talking about, say, some system is giving a good logs analysis, some system is giving some matrices. So can't we use the same system and send this data to some tool which can give you kind of a global kind of a picture what is happening? So can that be done with your tool?
Yeah, again, I'm not trying to compare observability tools here, so I don't want to get into that discussion. But the point is, yes, that is what full stack observability is all about, right? It's about trying to make sure that you have a telemetry pipeline of data that's coming in from your application, which you're going to, like, you know, observability tools don't differentiate between those stacks that you're going to send that information from. What we are looking for is, you know, what is the information that you're actually sending us, so that once you send that information, you know, you can get a visibility to what's happening in your system. And it's also about trying to have an ability to stitch together, right? Like, because as I said, right, you can't start with the logs, because I'm sure logs have all the information that you're looking for, but in an incident when you're getting there, if the first place you go look for in the logs, it's going to take you much longer to solve the problem. So it's important that the data flows in, and once the data flows in, you can categorize it on metric, event, log, and trace, and then have the four things stitched together. I think that is really what full stack observability is all about. But yes, tools should be doing that, you're right.
No, I see most of the organization, they kind of put logs somewhere, take the observability. So standard way of they do that. But my question was, like, can we use the same tools? So they already have data, they already have matrices. Can we use those data and create something out of it and bring some analysis?
Not all tools in the market do full stack observability. That's the first problem. The second problem is, you can do it, but you're putting the effort in order to do that. So you're buying a product, you're paying a fee, a license fee, and you're not getting a value out of it if you have to go do the work to stitch all of it together, right? So not only are you paying them a fee, you're also now spending engineering hours to go and tie all these things together, which in my view, it's not a great situation. Then you might as well go build your own tool, right? Like, why take something? So you should make sure that the evaluation of your tool is such that you're actually getting all of these together. And when you do that, then you're going to save your engineering efforts to go do something else and have the vendor do what they're supposed to do, instead of having to do something on top of what they're doing. Yeah.
Hi, thank you. Thank you for explaining all of this. My question is, what is the biggest challenge you guys are facing in solving this problem?
Yeah, I think one of the biggest challenges you have is that each customer comes with a different tech stack. So you need to be able to have telemetry that you're able to capture from all these different tech stacks, whether it's a Java application, C# application, Golang application. Like, how do you make sure that you build generic enough platforms that can do this? That's definitely one of the challenges. The format of data that's coming in is another challenge for us, because every application is instrumented there. There are some standards now like open telemetry which have come in, which we are trying to move to, which will help us get to that standardization of what information comes in. But we spend an insane amount of time trying to go and build ability to decipher the streams of data that are coming in and kind of classify it into what we require in order to paint the dashboards and get the information up to customers. And then we deal with the sheer volume problems, right? Because the amount of data that we bring in is like in exabytes, and like we are one of the largest consumers of Kafka in the world, right? So for us to deal with some of these things, it's the scale, the sheer scale is a problem. So yeah, these are some of the, there are many more, but I'll stop here. There are quite a few hands actually, 2 or 3 hands.
Yeah. I want to know how long does it take to train, on my data? Because you've been coming from your data and my use case may be different, right? So like, is it plug and play and just start using it, or probably you need to spend some time with us and then you will come up with a solution?
It's actually plug and play. You don't have, there's no training that needs to be done here, because primarily you're going to feed the data in, and then our engines are going to take care of doing the models are going to be mature enough to actually go and know what's actually there and understand. There could be some, depending on how we fix some of those formats, and if the best thing would be if you can move to like open telemetry and kind of push data in, it starts to become easy to figure out what is coming in and the data that's actually coming in. There could be some model training that needs to be done for specific use cases, but by and large today, if you look at our products, they're all plug and play. You just come in, you just instrument, is probably like a cookie cutter kind of way of implementing, and you get your dashboards and you get your metrics pretty straight off within a few minutes.
Okay, thank you.
Hello. Can I go ahead?
Sorry. Yeah.
I'm Sri Krishna. Nice presentation. So what kind of use cases along the lines of AI use cases, intelligent kind of thing you guys are working on from observability perspective? See, there are a lot of LLMs, AI agents, things like that are kind of coming up, right? From that perspective, what's kind of generally in the roadmap?
Yeah. So what I was kind of mentioning, some of the things which I mentioned, again, I don't want to go into detailed roadmaps of what we have, but some of the problems I just described in terms of solving predictability versus observability, right? Like our generation so far has been about observability, but we should be moving from observability to predictability. We talked about the use case of incident management, how much time is wasted and spent on that, where I think 70 to 80% of what we do is mundane set of tasks on repetitive incidents that actually occur, which we really believe can be entirely automated, and you can give the productivity back to engineering teams to go do other things which are probably more important to their business. But these are kind of, and then you also look at things like Copilot and few things where you say that, hey, can I even generate like for example, you have documentation, right? You build a product, you have documentation. So tomorrow, can I use the code to regenerate the documentation so that, our biggest problem is today code changes faster than the documentation. And so, you have a whole big team that's actually now going and managing the documentation which you have. Is there a way that we can actually say the source of truth is sitting in the code? So let me go and use that to kind of create the documentation so that every time the code changes, I don't have to worry about the documentation being up to date. Things like that, right? Like these are, I'm sure we're all dealing with these kind of problems and trying to work through them.
Thank you.
How data scientists and analysts get benefit from this particular tool?
Data scientists, was that your question?
Yes.
So I think, see, when we talked, like I talked to you about my Walmart experience, right? And data scientists were typically the people who were building those models for us and actually working on, I talked about demand generation, demand forecasting, and I talked about being able to predict, like, how much inventory is required in a store and things like that. I think those models also, like as you build them and deploy them, need observability on top of them to understand, whether how accurate is my model, what's actually happening, you know, am I getting the right information, is the data actually flowing? I think all of that, you know, as we build these AI models and AI systems, we'll also start to make sure that we are monitoring those systems using these observability tools. So for you as a data scientist, if you're building those models and you're deploying, more than building the model, it's actually after you deploy the model, and actually you need to look at it how it runs in the real road, right? Like in the real road rather than in the garage. That's when we'll be able to have these observability tools helping you to monitor your applications that you're deploying out there.
Hi, thanks for this. I'm Sivam. So after observability, the next thing is actionability, right? So are there tools out there which also do this? For example, if an anomaly is detected, do they also trigger actions based on that, and how does that work? Thanks.
Yeah, I think there are a lot of research that's going on into this. Like today, it's very configuration driven, I would say. Like you have to go and build a workflow, and then you say, if this happens, do this. If this happens, do something else. But in reality, we want it to become a little bit more automated, right? Like rather than somebody having to go and configure the whole thing. Like with the data that we have and the insights we have into the system, and the fact that we know that, you know, what we did in the last 10 times this incident occurred, the system can automatically trigger those corrections or self-healing, as we kind of call it, without having somebody to go and configure all of this, because there is an effort in even going and configuring these, right, and keeping it up to date and keeping on adding those configurations. And it's not a learning system that's actually going to come back and as new incidents come in, be able to take that information and go, you'll again have to go do some work on it. Today, that's how most of the systems work. There are automations, but they are mainly configuration driven.